looks like we are live. I am a few minutes early this evening because I got the setup went well, so I got set up a little early. I'm just going to start a little early. So, good evening, everyone, from a finally nice evening in the Death Valley region of California. We've had quite the summer this summer of monsoonal weather. And where the heck is my thing? Darn. Okay, I gotta somehow mute this because this thing is talking at me. I can't have it talking at me. Okay, there we go. Alright. We've had a lot of monsoonal flow this summer, and so it's just been clouds and humidity and wind and wind and wind and wind. So finally we got a nice break, and our fall has finally started. Got a really nice evening, so wanted to take advantage of that. And okay, so let's get this going, and then I'm going to need to do this. And let's get our monthly challenge opened here. I should probably turn off the test pattern and go to our page here with the monthly challenge. And so one of our members, Herseycart, put together a nice little list, mostly of open clusters and galaxies. So take a look at some of that stuff. Okay, now what's our Cassiopeia? So Cassiopeia is pretty well open right now. Where's M39? Let's take a look at M39. In here, ding ding, find the right window. M39. Okay, it's going to be somewhere in here. Somewhere around Cassiopeia. If I can just see it. There's M103. No, can't just see it. So we'll do the quick search. M39. Wow. Really? That's Cassiopeia? Way up there? Huh. That's quite a bit above Cassiopeia. Okay, well, anyway. That's fine. Let's go there. Should be a nice little open cluster up here. Let's do a plate solve on that. Make sure we got it centered, but this is probably it. 1/4 of a degree, yeah. It's probably about right. It's a fairly big open cluster. Yeah, there we are. So we don't really need to do. Nice thing about the clusters is don't need to spend a lot of time on them because they're very, very bright objects. In fact, I probably don't even really need to do any guiding, but what the heck. Okay, and let's back this off, and let's clear this out. And let's get you out of here. Let's get you out of here. Let's get you doing this. And let's get you out of the way. Okay, yeah, you can see there's some really nice looking little stars in there. Okay, and let's get our enhancements turned on here. Doop. Yeah, it's just a nice big open cluster. Let's go up here. Let's see what Wikipedia has to say about M39. Open a cluster, position 2 degrees to the south of the star Pi Cygnus. Yeah, it's in Cygnus. Yeah, which is what he said. I had this one and this one mixed up. Anyway, Cygnus is in a nice position right now because it's really nice and high up. 24 blue and yellow stars. It's around 9 degrees northeast of Deneb, which is the Northern Cross, which is very high in the sky right now. In fact, almost dead zenith. The cluster was discovered by Guillaume Le Gentil in 1749, and then Charles Messier added it to his catalogue in 1764. When observed in a small telescope, the low power of the cluster shows around 24 members, but is best observed with binoculars. It spans an entire angular diameter of 29 arc minutes, so about half a degree, about the size of the full moon. It's about a little over 1,000 light years away. Of the 15 brightest components, 6 form binary star systems. Huh. Cool. Cool. I wonder if it says how many total members there are. Observed, it has 24 members, observed with binoculars. It doesn't really say how many total members there are, so. Estimated age, 280 million years, mass, apparent dimensions. Oh. Uh-oh. Clicked the wrong button. It has a total mass of about 232 solar masses. I don't know. So a couple hundred stars maybe. But it is a great binocular target. It's one of those big things. It's 29 arc minutes, so about half a degree across. So, which fills about half of my sensor. This sensor here on my color camera is about a degree in total square, and so this fills about half. So it's about half a degree in size, which is a nice size for a small telescope or binoculars. And we're going to look at at least one more nice binocular target here in a few minutes, which is the double cluster, which is an even better binocular target. Nice big bright things to see. Let's do a color balance to see if we can pick up some of the colors. But saturate the colors a little more. Hey Dennis, thanks for stopping by. Good to see you. Getting up early tomorrow, huh? Oh, I hope it's for doing something fun. Getting out early, an early start on your weekend. Hopefully it's not that you have to work or something. And thanks for reminding people about hitting the like button. It is nice to be able to if you guys hit the like button, then I think it shows up on more people's, I don't know, somehow YouTube says, oh, people like this, it must be a real thing, and they put it out to more people or something, so. Yes, hit that thumbs up button if you would be so kind. But yeah, it's a nice big thing. Hey Mike, thanks for being here. 11:30 on your Friday night. How's things in Virginia? We finally got some nice weather here after a long, muggy, monsoony summer. M39. Okay, another. It's a great binocular target, though, and for those who are looking for it, there is the Northern Cross, Cygnus, the Northern Cross, or Cygnus, the Swan, and it kind of points right at it, right off the top of the cross itself. So it's right between Cygnus and Cepheus. So it's a great binocular. There's a lot of great stuff to see. I mean, just sweeping the entire band of the Milky Way with binoculars or a small telescope is a spectacular thing to do, but M39 is something that you can see right in there, so that's pretty cool. Alright, let's see what is next. Cygnus, okay, yeah, so this is going to be Western Veil Nebula. I think I'm going to save that for a second and save that for a minute. Let the sky is not completely fully dark yet, so it's best for open clusters, so we're going to do that. NGC, the owl cluster. Okay, and that's it. Was that in Cygnus again? No, that's in Cassie. Okay. Owl cluster. Okay. Go to the owl cluster. Main scope is down for mountain maintenance, but it was so clear last night I did some good old visual with my 4-inch APO. Yeah, you know, I'm actually going to be going to a star party with the Las Vegas Club this next weekend, not this weekend, but the next weekend. And there's not a lot of power on the telescope field, and I don't have this rig set up to work off the mains yet. I don't have a battery pack or whatever. So I think I'm going to end up I'm just going to bring my Astro binos and my small little 130 collapsible reflector and just do some visual myself. I love doing imaging, and so that's all I ever do anymore, and I never do any visual anymore. So I'm going to just spend the weekend doing some visual observation, just with binos, looking at these kind of objects, which are larger, prettier objects that are great for small scopes and binoculars, and you know, just kind of enjoy doing that. All right, let's knock you down again. We do not need to have lots of exposure time for beautiful clusters. Okay, so Cassiopeia, 60 stars. Okay, and that's 457. I got a little bit of smudging in here, and I'm wondering if my collimation might be out a little bit on my scope. But there's the owl's eyes right there. The problem with doing using a camera is, even with such short exposures, you get so many stars, it's hard to see the shapes that the names refer to. Many of these objects were named, you know, through visual objects, and so when you which didn't see nearly as many stars. And so when you look at it through the camera that sees a lot more, it oftentimes doesn't. You get so many stars that you can't actually see the object. Let's turn the background music on. See how that works. Let me know how my sound levels are, microphone versus background music, etc., etc. I tried listening to my last one, and for some reason my microphone was just really soft. I don't know why. So I've moved it closer to my mouth tonight. Hopefully you can hear me okay, but let me know if it's how the sound of my voice is relative to the background noise, and I can adjust as necessary. Michael asks, has it cooled down for me here yet? Yes, it has. Our fall has finally started. Our days right now are getting up only into the mid-90s, which compared to the 115 plus that it was a week ago. We had a crazy late Indian summer, last week of August, first week of September. It was just nutty out here. It was over 115 every day. And so now it's like 94, 95 and getting down into the 60s at night, and it's just beautiful. September's one of my favorite months. Not because it's particularly cool, but it's just so much more comfortable than the July and August that came before it, that it just feels really nice. So finally our fall has indeed begun, which is very nice. Okay, thanks for letting me know, Michael. We got good sound. So these are the eyes of the owl here. But the shape of the owl is almost completely lost because the camera picks up so many stars. Yeah, and then you've got the kind of the wings that go out here, and the two eyes. So you've got the two eyes and then the wings that kind of go out here and here a little bit. But again, the sensitivity of the camera picks up so many stars that it kind of gets lost. I am not using the hilarious but effective cinder block mount anymore. No, I'm actually I have sold the wedge and the evolution, and because I got an AVX, and so I've finally bit the bullet and have gone to an equatorial mount. I wanted to start guiding, which I am doing, and in fact I can even look at see how that's. I haven't even been looking at that. Yeah, we're doing pretty good. I've actually started doing guiding, and guiding just works better with the with an equatorial mount. Certainly better than with the evolution. And so yeah, I've gone AVX, and yeah, I've started guiding, and I'm doing up to 3-minute exposures now. I've started to use narrowband filters. When the moon is out and my skies are bright, I just start using narrowband filters, and so kind of gone and started to do that. And so yeah, the cinder block pier is gone. Well, it's still sitting out there, but I don't have any use for it anymore because the AVX actually comes with a 2-inch stainless steel tripod. It actually comes with a great tripod, which is really nice. So yeah, that's what I'm using now. Okay, M39. There goes M39. What's going to be next? I'm going to come back to Veil. Come back. Okay, let's go to double cluster. Yeah, 884. Double cluster. And double cluster. No, other way. Is down. Oh, where are you? I can actually find it. I can actually find it naked eye easier than I can. I think it might still be actually a little bit too low. We may have to come back to it. Yeah, it's right there. Yeah. It might be okay. Yeah, this is going to be the double cluster here. Okay. It's a little bit low, but not too bad, I think. I'm almost shooting into a telephone pole, but I think we're clearing it. Go ahead and plate solve me. Yep. Move. Put that in the center. That spot right there. And that should be about right. Cool. Okay. That should be about it. Start imaging. You down, you out, clear you up, and start again. Okay. Yeah. Another big, bright, beautiful, binocular-friendly object. Double cluster. 884. And you can actually see it naked eye between Perseus and Cassiopeia. It's a nice, bright smudge in the sky. If you are... You've never done plate solve like that. Well, actually, I never have either, but I think that's something Robin added recently. So, basically, this is a tool in SharpCap where you can basically decide, okay, I'd like this spot here to be the center of the object, of the image, and you can turn that tool on and double click in it, and then it will automatically recenter it for you. But it requires a plate solve to do that, and if you don't have a current plate solve, when you do it, it automatically does the plate solve for you. So that actually didn't involve any sequence on my part at all. I was just able to use the tool and then double click. You know, when you started, probably noticed when I started the tool, it said you've moved too far away from your last plate solve or whatever. And so when I double clicked, it just automatically started to do the plate solve on its own. So the tool is smart enough to do that. Yeah, I'm not on the latest one, but I'm on one of the later ones. And so yeah, it actually didn't involve one. It didn't involve one of my sequences like up here. The sequences that I use for my going to the next target and starting imaging, depending on the camera. That was just a built-in functionality in the Pixel Center tool within SharpCap. Robin is constantly improving and updating the software, and it's really just, it's the most awesome EAA piece of software that there is. And there's other pieces of software out there, but this one is by far the most awesomest, in my opinion. So, ASI Air is, you know, tried to make a sort of competing product, but they got a long, long way to go. And now that Robin is basically working on this on SharpCap full time, it's just going to take off. Yeah, I use ASTAP as well. It's very fast, and so yeah. But there's double cluster. Beautiful, beautiful cluster. Maybe darken our background sky a little bit. But if any of these sequences, if you want any of these sequences, I can certainly send you these sequences, and you know, you can definitely use them all you want. That's what Doug did for his live streams. He asked for my sequences, he took them and then modified them slightly for his own uses. And but yeah, they're easy to create and easy to share. They're just little files, little text files, so they're easy to share. So I'm happy to share them with whatever, whoever. They're really just basically you kind of plug and play them, and it just creates a file that kind of looks like this, and just a simple high-level language, programming language. Pretty easy. Oh, okay. So I already sent you some in the past. Yeah, go ahead and PM me. I can certainly send them to you. Double cluster. Beautiful binocular target. All right. Again, we don't need to spend a lot of time on star clusters. They're so nice and bright. Okay, now in Cepheus 7380. Wrong window. Cepheus NGC 7380. Go. Alright, looks like maybe there's a little nebulosity with us. Oh, it is a nebula. It's the Wizard Nebula. Okay. Harry Potter and the Golden Snitch, huh? Alright, let's just pop a quick plate solve on this. Should be pretty close, but never hurts to check. 0.15 of a degree. Let's see if we can pick up any of the nebulosity. So I guess with this one we will let the full 60 seconds go and see if we can get some of that nebulosity to show up. Alright, so this is going to be NGC 7380. Let's see what Wikipedia has to say about this. NGC 7380. It's a young open cluster of stars in Cepheus, discovered by Caroline Herschel in 1787. The surrounding emission nebulosity is known colloquially as the Wizard Nebula, which spans an angle of 25, looks like 25 arc minutes. So again, that would be close to half a degree. Okay, and now we got, because we had this adjusted for much shorter exposures, we need to readjust this. Oh yeah, you can see the nebulosity in there. Do a quick color balance. Yeah, you can definitely see the nebulosity in there. And because we've gone into, we're into the band of the Milky Way here. So we're going to be a pretty dense star field. So this actually would be a great target for my narrowband filters that I've started playing with. The narrowband filters knock down a lot of light pollution and sky brightness and other things, and also they knock back thick star fields like this. You still see a number of the stars, but not nearly as many. So it actually helps with objects like this that are just cluttered by all these beautiful sparkly stars, and it almost drowns out the object themselves. The narrowband filters really help bring that forward, so you can see much more of the nebula itself. William Herschel included his sister's discovery in his catalog and labeled it H877. The nebula is known as blah 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 in the Sharpless catalog. It's 142 in the Sharpless catalog. It is extremely difficult to observe visually, usually requiring very dark skies and an oxygen filter. The NGC 7380 complex is located at a distance of approximately 8.5 kilolight years from the Sun. 8,500 light years. 8.5 kilolight years. That's an odd way to put that, but okay. 8,500 light years away. The cluster itself spans about 20 light years across, with an elongated shape and an extended tail. Age estimates range from 4 to 12 million years. At the center of the cluster lies DH Cephei, a close double-lined spectroscopic binary system containing two massive O-type stars. This pair are the primary ionizing source for the surrounding hydrogen beta region and are driving out the surrounding gas and dust while triggering star formation in the neighboring region. Might need an O3 filter. Well, we don't quite need the O3 filter to be able to see it. It is definitely there. But yeah, if I was using my narrowband, it would show up a lot better. Yes, Michael, I do have an L Extreme currently, although I want to also get one of the Antlia Alp Ts and compare them side by side. I've heard some good things about them, and I want to actually try and get one of those too, and then sell off whichever one I don't like. But yes, I currently do have an L Extreme that I got off the Cloudy Nights classifieds, and I've been playing with that, and it's pretty cool. And like I said, I've just started doing it. I've only done a couple of sessions with it, and really, it's my full moon. It's my full moon astronomy now. You know, because I live under dark skies, whenever the moon is out, for the 2 weeks of the month that the moon is out, I just don't bother to do astronomy. Because obviously I have a lot of sky brightness. But there are some really gorgeous nights that go by. That the only problem is that there's a moon in the sky. So I figured I would pick up a good narrowband filter, and then any nights when the moon is in the sky, I can still do some great astronomy. It's just that I'll be doing narrowband stuff, and I'll be looking at a lot of nebulae like this. So write up a good review, huh? Well, I don't know about writing up a review. I'm not much of a writer, but what I probably will do is do some captures and post the captures that I get with each, and then people can draw their own conclusions based on the images that I'm getting. Try and make it apples to apples comparison, and everybody can make up their own mind. That will probably be what suffices for a review from me. But for a good extensive review, you should just see Jim Thompson's review, where he actually did. He does full-on scientific analyses and extensive testing of the things. And he did one earlier this year. He did a test, and that test included the Antlia Alp T and the L Extreme, among others. The IDAS NBZ was in there, and a couple of others too. A Triad was in there. I'm trying to think of the name, but anyway, I just blanked. But yes, and so he did an extensive write-up on all that stuff. And when you PM me, ask for that if you haven't seen it already, and because he posted it on Cloudy Nights, so there's a thread discussing it. So the biggest technical difference between the two, between the L Extreme and the Antlia, is that the L Extreme is a 7 nanometer narrowband, where the Antlia is a 5. So just a little bit more restrictive, a little bit narrower again, and so it just knocks down some more of the background, more of the star fields, and just really brings forward the nebula just a little bit better, and supposedly reduces the haloing too. One of the biggest objections to the optolong filters is if you get a bright star in the image, it creates a halo around the brighter stars in the image, and supposedly the Antlia does a much better job with it. So, but again, I'd like to test it side by side, and so hopefully I'm gonna do that. But they're both spendy filters. The L Extreme is 300, the Antlia is 400, so it takes you have to cough up a chunk of change to get them both to test them. But if you can get a good deal on one finding used in your set, which I did with the L Extreme, but the Antlias are much harder to come by. They're not nearly as popular as the optolongs. Alright, let's try another color balance here, see if we're still on. Yeah, it looks like we are. I think we can push this stretch a bit more too. If we get a little more pop out of that. What did we say this was? A little over 1,000 light years away? It's about 20 light years across. No, distance of 8.5 kilolight years. So it's about 8,500 light years away. And about 20 light years across. Yeah, the triads. That was it. It was the Triad Ultra was one of the filters he had in there. And what was really surprising, even though it was 3 or 4 times the cost of the L Extreme, he couldn't tell the difference between the two. He said the Triad was definitely not worth the extra money. Yeah, the Triads and the Chromas and those really high-end spendy ones. Yeah, you can definitely spend a lot of money on that stuff. I have a friend who has a full set of Chromas, and that's a chunk of change there. But they're only like 3 nanometer. I mean, they're like super narrow band. So, I don't know. I guess the narrower you get, the more you gotta spend. But anyway, there's the Wizard Nebula. I think it came out pretty well. especially considering this is completely unfiltered. I do not use any filters, like I said, unless I'm doing my narrowband stuff when the moon's out. So, but my normal dark sky astronomy is completely naked, no filters of any kind. So, you know, when I increase the stretch to get the nebula to show up better, of course, the star field just wants to pop out all that much more too. So, the stars don't look too bad in this one. I don't know how my guiding is doing. Haven't been looking at that very much. Yeah, down to about 1 1/4. It's not so bad. Put this in here so you guys can see it. Not that very many people are interested in guiding, but yeah, I'm down about 1 1/4, which for an AVX is not too bad. Not too shabby at all. Okay. Very good. Wizard Nebula. Wizard Nebula with NGC 7380. Okay, so I think those are all the open clusters, which I wanted to do first. Now we're going to go and do, yeah, and I should get to that pretty soon. So let's go ahead and do 6960, which is another thing you can actually see naked eye. Well, I should say something that you can see very easy, and here we are right here. These are the Veil Nebulas, and I'm going to do them both, because why not? So here's the one he said to do, which is west. They're both getting close to meridian, so I want to catch them before they go on the other side of the meridian. But they are some beautiful targets. Okay, and I think we're going to have to, let's pop a quick plate solve. So I think it's going to be here, so it's going to need to move it down a little bit more. Yeah. Okie dokie. Let that settle in for a second. Come on. And we'll start the imaging. These are also images which these are also objects that fit nicely within my 1 degree field of view. All right. $69.60. NGC 6960, and this is basically it's a supernova remnant. And so what this was this is all a supernova remnant that blew up and has expanded out into space. All of its gases have pushed out into space, and some areas of it are so bright that they've actually, been given their own names. And so this is the West Veil, or the Witch's Broom, and this is East Veil here. And you can actually see, what is it, the Triad? I forget what it's called. Anyway, this piece in here also has its name. And see if I can, no, I don't think it's gonna. Yeah, it's not gonna do it. Anyway, gonna reselect this now. Really? There we are. And so this was just a supernova that blew up, and so all of its gases are still expanding and spreading out, and then other stars have formed and are igniting. Basically, they're making the gases from that supernova glow. And so that's what we've got here. Yeah, see, and you can see it right here. This is another object where the nebula filter helps a lot. And it looks like my blacks are really clipped, so that means this is too far to the right. This over here, that'll show up a lot better now. Yeah, so you can see it's a nice way. This is another thing, again, where the narrowband filter knocks the star field down, makes this star a lot dimmer, and leaves this as bright as it already is. It doesn't touch the nebula, but it knocks everything else way back, and really makes it pop a little more. But it's still a beautiful, beautiful little thing. Let's see what. The source supernova was a star about 20 times the size of our Sun, and it exploded between 10 and 20,000 years ago. At the time of the explosion, the supernova would have appeared brighter than Venus in the sky and visible in the daytime. The remnants have since expanded to cover an area of the sky roughly 3 degrees in diameter, about 6 times the size of the full moon. While previous distance estimates have ranged from 1,200 to 5,800 light-years, a recent determination of 2,400 light-years is based on direct astrometric measurements. It says also a strong emitter of radio waves and X-rays. It was first observed in 1784 by William Herschel. When finally resolved, some parts of the nebula appear to be rope-like filaments. The standard explanation is that the shock waves are so thin, less than 1 part in 50,000 of the radius, that the shell is visible only when viewed exactly edge-on, giving the shell the appearance of a filament. At the estimated distance of 2,400 light-years, the nebula has a radius of 65 light-years, a diameter of 130 light-years. The thickness of each filament is 1/50,000th of the radius, or about 4 billion miles, roughly the distance from Earth to Pluto. Undulations in the surface of the shell lead to multiple filamentary images which appear to be intertwined. That's it. Yeah, the Pickering's triangular. Yeah, the triangle. Pickering's triangle. Yep. That's it. Definitely pretty objects. So basically they're saying each one of these little wisps is about the thickness of the distance between the Earth and Pluto. So most of our solar system, at least most of the radius of our solar system, not the full diameter of it. but it's a pretty big object. So approximately 15,000 years ago, give or take. I like trying to stretch it to bring the nebula out, but as always, the more you bring the nebula out, the more you bring the star field out. So it all kind of comes out together. Really the best thing for it is filters and more time. And hopefully, if the weather stays decent, I'll maybe do a narrowband night too. Hola, Joy. Thanks for coming in. Appreciate you staying up late and coming in to see me. So this is the West Vale Nebula, or the Witch's Broom. It's a supernova remnant. In fact, I might have been looking at this when you were here the last time. I don't remember. I like looking at this object, so it's a summertime object. I look at it a number of times in this time of the year. So you're welcome. I'm glad you find it awesome. Yep, it's called the Witch's Broom. And obviously the handle up here, and the wispy broomy part down here, and that's where you ride. You sit there, hold on there, and phew, you go. So it's this here part of this whole area is just the explosion from a supernova that occurred approximately 15,000 years ago, and it would have been bright enough to be seen in our sky in the daytime. It's about 1,500 light years away, I think, is what. So this is just the explosion that occurred, and it was a star about 20 times the size of our Earth, of our Sun, and it just exploded. And this is all the remnants from it. All the gas and all the material from it is just expanding and expanding. And so this is just one part of it, called West Vale, or the Witch's Broom. And as it expands outward, starlight, other stars in the area, light it up and make it glow. And the blue parts, you can see there's red parts and there's blue parts. And typically speaking, the bluish-greenish parts are oxygen, or oxygen-3, and the red parts are hydrogen, typically hydrogen alpha or hydrogen beta. And so when I use my narrowband filters, my nebula filters, those are the two narrow bands of the spectrum that it allows through while it blocks everything else. So things like light pollution and sky brightness are knocked way down, and the star field is knocked way down. Almost all these stars, especially the little tiny spots, basically disappear. It's not that their light disappears, but it's just that so much of it disappears that they essentially wink out. And it really allows the nebula to come forward. But it's a beautiful thing. It'll give us another minute or so, and then we'll go do East Vale, which is actually the brighter section. But the witch's broom is nice. See how our guiding is doing. Ooh, down 1.17. I'm drifting low though. Might have to switch sides. Okay, so let's go and do the east veil. Alright, and that's this part down here. Alright, is this part down here? Come on, you gotta go on, let me select you. There it is. Whoop. Okay. Do a quick plate solve on that. Five 1/100ths of a degree. You know, I would like, I should suggest to Robin that if it's like less than 1/10 of a degree, to just blow it off. It's just really not worth trying to do that. Alright, so here's going to be the other side, the other bright spot, which is going to be East Vale. So, all right. See how you do here. I have to swap you around right now. Let's clear this, see what happens. Okay, so here is going to be the other side of it. So this is going to be this side of it here. So we just did West Vale, and now we're going to be doing the eastern side. And I didn't really try and frame it up any better. If it's off, we'll do the pixel centering thing again and get it a little bit better aligned. But I think it. We'll see what we get. This first sub should tell us. Yeah. So what I think we want to do okay, so it already moved. So let's turn this off. No, not scripting. Sequences. Start imaging. Okay. This will get it better centered. Alright, but we just have to wait for another image to load here. So, just one minute. Okay, so now the open cluster, yeah, so this one, the West Vale, which is Broom, that's the one we did already. Yeah, so we're actually doing this other piece, we're doing the East Vale now too. So this was the one he said to do, so this is going to be a bonus. But since you're here, why would you not do both of them, since they're both beautiful? And so we're going to do them both. And this one is the brighter one too. This one is a little bit easier to see without filters. It's a little bit bigger and a little bit brighter. So yeah, there we go. That got it a lot better. I got it centered pretty good. So again, this whole entire large region is all what used to be part of one star. Just a massive star, 20 times the size of our own sun. And it just went super duper nova and just produced all of this material that is blown out into space. And yeah, pretty to look at, and it's amazing science too. Yeah, Beetlejuice. Yeah, the question is when? Could be any minute. Might not be for another 100 years. We don't know. We just don't know. Yeah, it's well, the science part, Joy, is really kind of fascinating. It's just amazing how massive these things are, and you know, it's basically these stars are what produced all of the complex heavy metals and everything that makes up everything, from the Earth to our own bodies to everything. You know, basically hydrogen and helium, I think, were the only two real elements that were around, and they're still the most abundant. Not helium. Hydrogen and... what am I thinking of? Anyway. But it took really dense objects like stars to produce the more dense items on the periodic table. And so that's why Carl Sagan always said, we are star stuff. We literally are made of stars, because all of the materials that make, the heavier materials that make up our bodies and our Earth and our cars and our smartphones, all of that stuff came from the interiors of stars. And so, you know, these huge objects, massive amounts of energy, massive amounts of mass, massive amounts of stuff, have really formed everything. And so this is just, you know, another manifestation of that beauty. The big recycling machine. Yeah, it is. Everything is just reused over and over again. Massive stars explode, producing huge fields of gas out in space that eventually recoalesce into smaller stars. And black holes, who knows what the heck they do. They could be the vacuum cleaner that feeds recycling machines and spits it out somewhere else as supermassive stars, and the whole thing starts over again. Who knows? But it sure is pretty too. Not just sciencey, but beautiful as well. Stars aren't too bad. Not ovals. Did it create a neutron star? I don't think. Well, not according to the write-up that's in here. It just says that it was supernova 20 times more massive than the Sun. Components. Observation. No. The Veil Nebula is expanding at a velocity of about 1.5 million kilometers per hour. The Hubble Space Telescope took pictures of it in 1997 and then again in 2015, and the expansion was directly observed. So they could literally see in that 18-year time span that it had grown significantly bigger. 1.5 million kilometers an hour. So, and this thing blew up approximately 15,000 years ago, give or take. So it's just been expanding and expanding, and it's still blowing outward. Thanks for showing up, Joy. Good to hear from you. Glad you were here. Sleep well. Sweet dreams. Well, they fade relatively quickly, yeah. The supernovas themselves don't last long. They're such high energy events that they can't last very long. But their remnants stick around for a long time and eventually even reform. You know, some of this gas and dust will probably reform new stars. Much smaller than the original, but they'll probably just form new stars. All right, well, that's coming along nicely. What else we got going on here? So we've got supernova remnants. We've done all the open clusters already. Okay, so now we're talking about some galaxies. Normally I like doing galaxies with my monochrome camera, which is much better geared toward it, but still, if they're fairly bright, the color camera should do a good job, although not as nice a job as it does on the Veil Nebula. So, but there's our East Veil. So let's go ahead and close that one out and go do a couple of galaxies. So our first one, is going to be what? 7331. 7331. Well, that's interesting. Two different listings, one with the space and one without, huh? Oh, this is part of the Deer Lick. Oh, okay, yeah. Okay, Deer Lick. So we're going to do the Deer Lick and Stephan's Quintet, which are all things that are usually part of galaxy season, but I'm not good. No, I'm not doing a meridian flip. Okay. We're actually just coming down from the meridian. So we'll do the Deer Lick, and thanks for stopping by, Michael. Really appreciate you being here. And yeah, send me a PM on cloudy nights, and I'll send you those sequence files. And whatever else I said I was going to forget now. Whatever else, what I saw, else I said I was going to. Anyway, let me know what I need to send you, because I've already forgotten. But yeah, we'll chat. But thanks for being here. Appreciate you coming and chatting. It's always nice to have somebody who's willing to chat, rather than just me being here prattling on to myself. So thanks for being here. Okay. So the Deer Lick, and that's going to be a grouping of galaxies. Let's put our little thing here. Yeah. I may even want to move this a tad. I may have wanted to move it slightly, but we'll see what happens. Well, I'm glad you appreciate me prattling, because some nights that's all there is. Some nights people aren't too chatty, so it's nice to have somebody who is. Yeah, okay, I got all of them. See, there's the grouping of 3 up there. So, yeah, and there's just a ton of galaxies in here. Just a ton. There's one there. Anyway, there's a bunch. There's a bunch in here. A bunch of these are. This one's probably one. Anyway, we will zoom in and focus in on that. This one is the big bright one, Caldwell 30. But there's quite a few more up here, and some of these are fuzzy. They're not stars. Stars are pretty sharp. They have pretty sharp boundaries. Anything that has a fuzzy boundary, it's going to be a galaxy. This one here is going to be a galaxy. There's just a lot of them in there. And in fact, one of the other nice things about SharpCap is you can use the annotation. How often do I do this? Well, that is entirely weather dependent. Usually I do at least a couple a month, 3, 4 a month sometimes. Typically around the 2 weeks that's the dark of the moon. Although, like I was saying earlier, I have started doing some narrowband imaging when the moon is out. And but usually I do at least 2 or 3 or 4 a month. But it depends on the weather. This summer, unfortunately, we had so much monsoonal flow here in the desert Southwest that it was just clouds and humidity and wind, and it's just been a nasty summer. So I think I only did 2 or 3 the entire summer this year, which is unusual. And I did do some broadcasting on Night Skies Network, but I usually do broadcast over there when I when I don't have time to announce it ahead of time. If it's just, oh, I go out and the night looks nice and I've got the time, and so I just go out and do it, and I just pop on a Night Skies Network and broadcast on there. I don't bother doing it on YouTube. But normally I will do it on YouTube if I can get a day where the weather looks good in the morning. I don't trust the forecast much beyond 24 hours, so I can't say, like, I don't like planning it saying, okay, well, 48 hours from now it looks like, not tonight but tomorrow night's looking good. I can't really, things change so fast that I can't really do that. Weather can change from day to day. Even today it was supposed to be nice and calm, and by the evening the wind had started to pick up a little bit, so I'm kind of moved around the north side of the house to get shielded from the little breezes that are kicking up here. But the weather changes so quickly out here that I can't really plan more than about 12 hours ahead. So I check the forecast in the morning, and if it looks good, then I'll put out announcements for that night. But I can't do it like for 2 nights, or 2 nights from now or 3 nights from now I'm going to do it, because you just can't tell. Even if the forecast says it's going to be good, you just can't tell that it's actually going to be. So I have to play it by ear, and the morning of, if it looks good, then I'll make the announcements. But usually I try and do at least 2 or 3 a month if the weather is agreeable. And now that our fall is finally here and our monsoonal crap has broken, I might be able to do some more here. So looks like the next couple of nights are going to be windy again, so probably won't be able to do anything until next week. But hopefully I'll be able to do something again next week. We'll see. We'll see what happens. Okay, so this is 7331. Well, let's see what we can see about this. NGC 70, let me prattle on this. NGC 7331. Yeah, or the group. An unbarred spiral. It's about 40 million light years away. So it's not one of our nearest ones, but not too far away. Discovered by William Herschel in 1784, it's the brightest galaxy in a field of visual grouping known as the NGC 7331 group. Okay, yeah, and that would be these guys here. In fact, let me turn on the annotation, which will tell us exactly. View sky image annotation. Oop, click. And this is another really cool Oh, it has moved too far. Oh, come on. Alright, fine. We'll do a plate solve only. But one of the really cool features that's in one of the really cool features is he added an annotation feature. There we go. Okay, so which involves this panel that has all the objects, but then the objects are also all marked in here, and you can see there's quite a few galaxies in here. But the dear lit group is all of these guys here. 7340, 7337, 7335, 331 is the big one. But he's got some double stars marked in here too. That's kind of cool. But this is kind of the dear lit group up here. And then these guys over here, there's a nice little grouping in here. It's the HCG 692 grouping. There's like, some of these look like some nice little spirals that are in here. Can't zoom in too much with the color camera because we get too pixelated too quickly. The mono does a better job. The 183 does a better job with this. But yeah, you can see even this is a galaxy. This is a star with sharp edges, and this fuzzy edged is a lenticular galaxy. So there's just a bunch. Oh, here's one here. MAG 18. PGC. Peculiar Galaxy Catalog. So MAG 15.5. Yeah, look at that. Look at that. A spiral. It's got a bar and a ring. Yeah, you can see a bar there and a ring in it. Yeah, this is one of those spots where there's just galaxies galore. There's another one. There's a faint one, but yeah, you can see it's sort of a wispy, spidery arms on it. I do use Astrospheric. It's one of the things that I do reference. I found it less accurate for my location than weather.gov, which is my preferred weather site. But I do use it. I do reference it. It's a handy site. But I have not found it to be quite as good as my own weather.gov site. So. Yeah, okay, so the other members of the NGC 7331 group are 7335, 36, 37, and 40. Yeah, so that's all the ones in here. 35, 36, 37, and 40. So these are all part of that group. This whole little thing in here. And these are double stars here, but these are all part of the NGC 7331 group. So, alright, we'll turn that off so we can see the pretty galaxies a little bit better. All that clutter in the way. But 7331 is similar in size and structure to the Milky Way, and is sometimes referred to as the Milky Way's twin. However, discoveries in the 2000s regarding the structure of the Milky Way may call this similarity into doubt, particularly because the latter is now believed to be a barred spiral compared to the unbarred status of 7331. So the Milky Way, they're saying, is now a barred spiral, and this one does not seem to have a bar. It's just a spiral galaxy. In spiral galaxies, the central bulge typically co-rotates with the disk, but the bulge in 7331 is rotating in the opposite direction to the rest of the disk. In both visible light and infrared photos, the core of the galaxy appears to be slightly off-center, with one side of the disk appearing to extend further away from the core than the opposite side. Multiple supernova events have been observed in this galaxy throughout the years. A 1903 photographic plate from the Yerkes Observatory shows a magnitude 16.6 candidate transient that may also have been a supernova. Cool. Alright, so there's the Deer Lick group. And then these up here were pretty nice too, a PGC group. This little PGC group of spirally, wispy ones. Cool. Alright. Let's move on to Stephan's Quintet. Here we are, Stephan's Quintet. 7320. NGC 7320. Right nearby. Oh yeah, and then well, let's see if we can get that in there. So let's put this star, let's go to this star, and we'll get all of them in one shot. Get all of them. Yeah, see, there's the other one there, and there's this grouping here. So that should do it. And let's go ahead and start imaging. I don't know how our guiding's been doing. 1.1. Nice. Yeah. Guiding again? Yep, we're guiding again. Okay, cool. Alright, Stephan's Quintet. And that's 73. I think 7320 was it. NGC 7320. NGC 7320. It's a spiral in Stephan's Quintet. However, it's not an actual member of the galaxy group. That's kind of funny. Let's just look at Stephan's Quintet. It is a visual grouping of 5 galaxies, of which 4 form the first compact galaxy group ever discovered. There they are, right there. And then Caldwell 30 we just caught as a bonus. Oh. Wait, what? Well, that was silly. This was the object we were already on, wasn't it? It didn't need to move at all. This is the same object we were already on. This is the NGC 7331 group, and this is Stephan's Quintet. For some reason, the annotation didn't identify that as such. But anyway, yes, we already had both of them in the picture. Huh. I thought Stellarium slewed to a different spot. But anyway, we had them in the picture to begin with. But in this case, we're going to focus more on these guys. But we were kind of already there, so. Group is the most studied of all the compact galaxy groups. It was discovered in 1877. The brightest member of the visual grouping, and the only non-member of the true group, is 7320, which has extensive hydrogen beta regions identified as red blobs, where active star formation is occurring. I assume that's this one here. Four of the 5 galaxies in the quintet form a physical association, a true galaxy group, Hickson Compact Group 92, and will likely merge with each other. Huh. Radio observations in the early 1970s revealed a filament of emissions. So let's go ahead and put that annotation tool back on. Yeah, see, this is 20 down here. Yeah, this big one here is 20. Yeah, I thought so. So there's 17, and then 18, and 19, and 20. Yep. Let's back off, because that's just too zoomed in. Yeah, it just calls it an HCG 692 grouping of galaxies. It's Stefan's quintet. Duh. Okay, let's turn off the annotation. Well, I'm glad you like it, Rainbow. I'm glad you're seeing some cool stuff. I think astronomy is pretty darn cool. Some of the stuff that's out here is just mind-blowingly beautiful, as well as incredibly scientifically interesting. Four of the 5 main galaxies, so 7320 is the only member. So this one here is the only member that actually isn't part of the physical group. 17, 18, and 19 are actual parts of the group. Space telescopes have provided new insight into the nature of the film. 4 of the 5 galaxies form a physical association. The same region is also detected in the faint glow of ionized atoms. Blah blah blah. Yeah, that's right. This was one of the things that one of the first objects selected by the James Webb Telescope to take a picture of, and we did get some pretty cool pictures of it from the James Webb. Redshift, infrared members, 17, 18, 18A and 18B. Yeah, so these are both galaxies A and B, and then 19 and then 20. So these 4 here, 1, 2, 3, and 4, are actually physically part of the group. This one is actually only visually part of the group. It's actually either a lot closer or a lot further away. Do they have that in here? I think they do. The distance away. Redshift. Emissions. Now if I go back, the brightest member is B, number of galaxies 5, right ascension, doesn't really say. Let's go back to the previous one. So 7320, the spiral galaxy and Stefan's quintet. So 20, this one here, is the only one that isn't part of the, it actually isn't physically associated with it. It's a much closer line of sight galaxy at a distance of about 40 million light years. The other galaxies in Stefan's quintet are some 300 million light years distant. So they look about the same. This one is brighter and slightly bigger, but it's like 8 times closer. So these other four galaxies here, which actually are together, are 300 million light years away, and this one's only 40. So these are much bigger and much brighter galaxies that are all together, and it's just visually, they look visually like they're together when they're really not. This one is much, much closer in the foreground from these other four. But because they all look together, they look like they're together, they're called the quintet. Pretty cool. 300 million light years away. And of course there's C30, which is down here, with the Deer Lit group that's down here. Milky Way's twin, although now we think that's not. Very cool. Alright, we've got one more object, and we're going to call it a night. IC10. Alright, IC10. IC10. Go. Oh, this is an interesting one. Starburst galaxy. Okay. Where are we on this? Oh, okay, so this is right in Cassiopeia. That's in a good place, so. Alright, let's go over to Cassie and see it. Alright, let's do a quick plate solve to make sure we're centered on it. About a quarter degree off. Okay. Okay, so this is going to be a starburst galaxy. Let's see what. Starburst. Galaxy. IC10. It's an irregular galaxy in the constellation Cassiopeia. It was discovered by Lewis Swift in 1887, and in 1935, Nicholas Mayall became the first to suggest that the object is extragalactic. Interesting object. I want to see how it resolves here. It is very unusual. Edwin Hubble suspected it might belong to the local group of galaxies, but its status remained uncertain for decades. The radial velocity was measured in 1962 and was found to be approaching the Milky Way at approximately 350 kilometers per second, strengthening the evidence for its membership in the local group. Its membership in the group was finally confirmed in 1996 by direct measurements of its distance based on observations of Cepheids. Most estimates place the galaxy 2 to 3 million light years from Earth, with some estimates ranging from 1.5 to 4.5 million light years. Despite its closeness, the galaxy is rather difficult to study because it lies near the plane of the Milky Way and is therefore heavily obscured by interstellar matter, right? Yeah, we just got a lot of not only stars, but dust and other material that's just between us and it, because it's right in the plane of our galaxy. The apparent distance between IC10 and the Andromeda galaxy is about the same as the apparent distance between Andromeda and Triangulum, which suggests that IC10 may belong to the M31 subgroup. IC10 is the only known starburst galaxy in the local group of galaxies. It has many more Wolf-Rayet stars per square kiloparsec than the Large Magellanic Cloud, or the Small Magellanic Cloud. Although the galaxy has a luminosity similar to the SMC, it is considered smaller. That's the Small Magellanic Cloud. It is considerably smaller, with an estimated diameter of around 5,000 light years. The galaxy has a huge envelope of hydrogen gas. Almost looks like it might be a good candidate for filters, but galaxies don't tend to respond well to filters, because galaxies are mostly starlight, and starlight is full spectrum. So most of the time galaxies wouldn't respond well to this, but galaxies wouldn't respond well to filters. But now this is just a hard thing to see because it's so close to it's within the plane of our own Milky Way. Yeah, see, so this is the Milky Way right through here. Yeah, you can see the fuzzy patch here, and it's right in the plane of our Milky Way. So we're looking right through the density of the arms of our own galaxy to look at it. So it has it's in just a pretty dense. You can see where the stars start to thin out a little bit over here, but in this part there's a pretty fair amount of star field density. So but I don't know. Maybe filters might do something for it. Probably just cut it all back. Who knows? Maybe one of my narrowband nights will take a look at it. See what he said about it. I've not observed this one. I was in a browsing area. I was browsing the area in K-stars to try and find something interesting for this list, and here it is. It's probably going to be the most difficult one on this month's list. I'm looking forward to giving it a try, and also looking forward to seeing what others are able to capture. Yeah. Well, ta-da! You can see some little bit of structure here. You know, if it was a nebula, I'd say that would be just a dark band. Dark nebula band in it, or whatnot, but it's not. This is a galaxy, There's an actual galaxy in the background that's well outside of our own galaxy, unlike a nebula, which would be inside our galaxy. And so this could be a piece of dark nebula that's just in our own oh, here we go. We just got photobombed by a by a satellite. But this could be a piece of dark nebula that's in our own galaxy that's just very much in the foreground. We are looking through, you know, like I said, we're looking through a bunch of crap to see this, and we're looking through our own, one of the arms of our own galaxy to look at it, so just a lot of stuff in the way. Bring that over, just darken it down a little bit, maybe stretch it a little bit more. Don't want to stretch it too much because all it does is bring the star field out. But it's a couple million light years away, much like Andromeda and Triangulum, or M33, which are our two closest galaxies. This one's somewhere in that neighborhood, but doesn't look as big or as spectacular. But again, unlike Andromeda and Triangulum, this one is in the plane of our own galaxy, so instead of looking away from the plane of our galaxy, we're looking through our own a bunch of junk to see it, so who knows? A lot of it could be blocked by dust and dark nebulae and whatnot that's in our own galaxy. It's just partially blocking it from our view of here on the Earth. Hit another color balance here. And there's 10 minutes on that. So that's about as good as we're going to get that. Kind of interesting. There's definitely a darker region up here and a little bit of structure here, which I think is probably just dark nebulae. Dark nebula in our own galaxy. But hard to tell. We're looking through so much stuff to look at it. Hard to tell if that's part of our galaxy or part of its. But interesting. Okay. And to finish off, even though that is our last object on the official list, yeah, that's the last thing. We haven't done anything. Everything else has been done. So, to finish off, I think what I'm going to do is we're going to do a detour and take a quick look at Jupiter, which right now is just right between two roofs. And so I should be able to take a quick look at it. And my scope is not designed for planetary work. It's designed for faint fuzzies, not planets and things. But so it's not gonna get a big pretty picture. But I guess we're going to have to plate solve to get on it, huh? It's kind of funny. It's a short focal length scope that's really designed to yeah, well, you know what? I actually don't need that. Let's see which way we go to do this. Nope. Not that way. There we go. That's better. It's a short focal length scope that's designed for faint fuzzies to collect light quickly, but not with a lot of magnitude and not a lot of magnification. And so it's not designed for planetary work. For planets, generally speaking, you want to have something with long focal lengths so you can get a lot of magnification. But it's good enough to at least see. Let's see. Come out here, and in fact, let's lock you in place. Let's drop our gain way down. Oh yeah, see, and you can see the 4 Galilean moons already. Yeah. And there they are. So there's Jupiter itself, which you have to blow out a bit to see the moons. Let's see what happens at 0 gain. Yeah. So there are the moons, and there's Jupiter. So all 4 of the Galilean moons are there. And then if we actually want to see Jupiter itself, we have to drop it down so the moons basically disappear. And then we might be able to see, maybe, although I might actually have to focus better, because it might not be focused well enough. Yeah, and you can see it swimming around. So you notice how it's jumping around a little bit. That's seeing. That's actually ripples in our own atmosphere that's causing that. What astronomers call seeing. So it looks like we've got banding in this direction here. But again, it's I think what I would have to do is probably go find a star and probably slew to a bright star in the area and check my focus. Come on. Yeah, Mag 2 should work. Let's go. Oh. Wow, really? Okay. That's not... Okay, I'm temporarily upside down here. Why am I... No, I don't want to go that way. That's the wrong way. Let's go up here. No, come on. Why won't you select what I want you to select? That. Alright. Let's go the other way. And we'll come back to Jupiter. I just need a bright enough star to check the focus. Let's just get our sequencer and get all these things reset back to where they're supposed to be. plate solve me back onto that star, wherever it went. And now suddenly plate solving is not working? Okay. There we go. Let's get the mask on it and check the focus. Okay. Now we should be able to go back. And that should be pretty well focused. Yes, okay. Now, drop the gain all the way out again. Yeah, so there's the 4 Galilean moons again. And now we will drop this back. Drop our exposure back. And see if we can't see. Yeah. Yep, there's the 2. There's the banding right there. I could see it earlier, but it wasn't very sharp. So, and look at it jumping around. Yeah, that's actually one thing Astrospheric did say about tonight, was that the seeing was supposed to be not very good. The transparency and the cloud cover were supposed to be excellent, but the seeing was supposed to be not very good. And that seems to be what we're getting tonight. It's kind of jumping all over the place because the seeing is not very good. But anyway, there be Jupiter. I don't know. Let me see if I can. I don't know if I can see Saturn from where I'm positioned. Nope, Saturn is just a little too low. So I think this will be it for the night. It's actually in a roof line, so can't see it from where I am. In order to avoid the breeze tonight, I set up on the north side of the house, so the whole southern sky is, at least the lower half of the southern sky is out. but Jupiter is kind of between two roofs, so I was able to see that. But yeah, that blows it out just a little too much, so this is about right. Yep. So anyway, there we are, a little planetary bonus. But that's going to be it for me tonight. So thanks everyone for being here. Hope you had a good time, and thanks as always to those folks who chatted. It's nice having folks who chat, and rather than just listening to me. So thanks everyone for being here, and have a great evening. I hope you have a great evening for the rest of your evening. So see you next time.